We will solve another important question from GATE 2025 physics. This question is from nuclear physics based on nuclear beta decay. Here there are two nuclei x1 and x2. They are undergoing beta decay, negative beta decay, resulting in nuclei y1 and y2 in the final state respectively. So what happens in a nuclear beta decay or in the negative nuclear beta decay? A neutron inside a proton, inside a nucleus, converted to a proton with an electron plus electron type antineutron. Here electron has been half, neutrino has been half. So depending on this total spin of electron and electron type antineutrino, there could be two types of allowed transitions. One, Fermi transition. In this case, the total spin of electron and electron type antineutrino is S is equal to 0. That means the spins of electron and electron type antineutrino are antiparallel. And the second possible allowed transition is Gamow-Teller transition. Here the total spin is 1. That means the spin of electron and electron type neutrino antineutrino are parallel. So we will find the spin whether. So the allowed transition should satisfy the conservation of total angular momentum. That means Ji should be equal to J final. Jf can be J of y, the final total angular momentum of the final nucleus, plus total spin of electron and antineutrino, plus total orbital angular momentum of this electron and antineutrino. If the electron and antineutrino were created at r is equal to 0, in this case they cannot carry any orbital angular momentum. So we will put L is equal to 0 in that case. So if for Fermi transition S is equal to 0 implies delta J, which is equal to J of x minus J of y, should be equal to 0. For Gamow transition, delta Ji should be equal to, or I can say J S is equal to J y plus S is equal to 1. So delta J could be either 0 or 1, except if delta J is equal to 0 or 1, then it could be in the allowed transition is Gamow-Teller transition, except Jx is equal to Jy is equal to J0. In this case, only Fermi transition can contribute. So we conclude that if a transition is allowed, x is going to y through a negative beta decay, and if it is allowed, if Jx is equal to Jy is equal to 0, then we will imply that this is a Fermi transition, and if Jx or delta J is equal to 0 or 1, then we will conclude that it is Gamow-Teller transition, or delta J is equal to 0. These are the possibility. So in first case, you see J is equal to 0, the final state has 0 is equal to 0, so that implies delta J is equal to 0 and J x is equal to J y is equal to 0. That means here only Fermi transition is can contribute. So this is a Fermi transition. But however, here you can see J is equal to 1, x is equal to x2 is equal to 0, J y2 is equal to 1. That implies delta J is equal to 1. That means here the allowed transition is Gamow-Teller transition. So the correct option is x1 x2, that one is Fermi transition, x2 is this. So correct option is option B.